Hello, geometry folks, and welcome to Surface Area of Pyramids and Cones. You're going to need your flip chart notes, and you're going to have to make some notes in the pyramid flip chart and the cone flip chart. But remember, you're going to just want to use one side of each of those flip charts so that we can put volume in there next week. All right, so you also need a pencil and a calculator, and we will get started. All right, so we have been talking about surface area, and now we are going to talk about surface area of pyramids. So the base can be any shape. It can be a triangle, a hexagon, a square. It can be a pentagon. So any of the pyramids can have any shape at the bottom. But what we need to know is that all of the sides are always going to be triangles. So you can see that in here on this pyramid, there would be a triangle, and there would be another triangle, and all those triangles meet at a point way at the top. Now, the most common pyramids have square bases. That's what we think about when we're talking about the Egyptian pyramids. They all have square bases. Now, this is what a pyramid looks like. So if you take a minute to draw this little pyramid out, I know it's kind of difficult to draw it, but go ahead and draw it anyway. See that you can draw it the best you can. What we have to know is that there's different parts of a pyramid, okay? Because the pyramid has a couple of different heights involved, we have to know which height is which. All right, so if I'm talking about the whole pyramid and I want the height of the entire pyramid from the top of all the triangles to the base, we call that the H height. That's the height of the entire pyramid. Now, if we're talking about the side, okay, and here's a triangle, when we find the area of a triangle, we need the height of the triangle itself. So we are not going to use the height of the inside of the pyramid. We would have to use the height of the pyramid, of the side of the triangle off the pyramid. We call that height the L height. It's actually called the slant height. Okay, so notice if I'm talking about that triangle, I'm talking about the height of that triangle. I'm talking about the slant height of that triangle, not to be confused with the height of the whole pyramid. Okay, so let me show you what that looks like here. And as we do that, you'll see that here is the height again of the whole pyramid, and then see off to the side here, that's the slant height. Okay, now if I were to show you more information here, this would be called a vertex because it's where all the triangles meet at the top. We know that that would be the base. This part right here and this part right here, and then the back and the back would all be called lateral faces. Now there's lateral edges and there's lateral bases, okay? Lateral means side. So if I put side there, maybe that would make more sense to you. But this would be some general, pieces of a pyramid, all right? So now if we were going to talk about the surface area and how we would find the surface area of a regular pyramid, and in this case it's a regular square pyramid, this is what the pyramid would look like. And if I were to dissect it, if you will, or take it apart, like we did that one day, we had all those little pieces, and then we put those shapes together. But if I were to dissect it or lay it flat, this is what it would look like. All right? And if you see, while you're looking at this, you will see that I have a base, Okay, whatever that base is, in this case it's a square base. So I would find this area. And then if you will, you would see that there are 4 triangles, okay, all the way around it. And you would find the area of all those 4 triangles. Now that's what you would have to do for every pyramid. Now if you didn't have a regular shape here, and these sides were all different, or maybe a rectangle, these 2 triangles might be the same, and these 2 triangles might be the same. So you would have to find it just a little bit differently based on the base of the pyramid. So let's go ahead and do one, or try one. We have a regular square pyramid here, and so we want to find the area of it. So the surface area, we'll have to find the area of each individual side and base. So the surface area is the area of the base, and because it's a regular base, that means all the sides are 8. We can then say we can find the area of the triangles, or this side, the lateral sides. And in this case, they're all 4 are the same. Okay, so surface area is going to be equal up to the base. So the base is a square, and base of the square is base times height. So 8 times 8, which is 64 units squared. Then I need the area of all these triangles, and 4 of them to be exact. Okay, so let's go ahead and find the area of this triangle. So this triangle is the one I'm looking at right here, this one that's off to the side. And we need a slant height. So here we have a triangle, and we need this slant height, and we know the base is 8. Now, if you look inside this pyramid, you might see that I have a regular height here. Now, here's my slant height. If I were to make a triangle inside this pyramid, a 3D triangle, could you see that the 3D triangle would have this side is 8, this side would be what? Well, if I take half of the base, it would be 4. And I need to find this slant height. I need to find that slant height because I need the height of that triangle in order to find the area of that triangle. So I need to using this 3D triangle inside the pyramid, I need to use the Pythagorean theorem to find that slant height. So I would say 12 squared plus 4 squared equals the slant height. 12 squared is 144, plus 16 equals L squared. 144 plus 16 is 160. That's my slant height. Square root both sides, and I will get 12.6 is equal to my slant height. So once I find my slant height of 12.6, I can find the area of that triangle. So the area of that triangle is base times height, slant height, of 12.6 divided by 2, and we're going to take that times 4. So let's first go 8 times 12.6 divided by 2. That's going to be 50.6. And then I need 4 of them. Okay, 4 times, not plus there, excuse me. So 4 times 50.6 would give me 202.4 units squared. And then I need to add that to my base to get my total surface area. So 64 plus 202, so my total surface area would be 266.4 units squared. Okay? All right, now let's go ahead and flip to the cone. A cone has a circular base and a curve that meets at the top, the point at the top. Okay, so the curve meets a point at the top. So here's what a cone looks like without the ice cream in it. So if you take a minute to draw this cone the best you can, notice we again have a height of the whole cone. The height of the whole cone is going to be an H, just like the height of a pyramid is H. And notice off the cone we have a slant height again, and again that is going to be called the L. And now this time we have a radius or an R because we have a circular base and circles have radiuses. Okay, so make sure that you write this down in your cone. All right, now to break it up further so that you can see even more of what's happening here, this is the vertex. H is the height of the whole cone. Remember, we're going to call that H. The outside of the cone is called the lateral surface. Okay, that's the sides of the cone. We, of course, have the base, and then we have that, again, that slant height off the side of the cone, which we call L. All right. Now, here is what a cone is going to look like if we dissect it. All right, so here's what it looks like when we dissect it, and we notice that the cone's base is a circle. What is the lateral side? Well, the lateral side is this sector, okay? And so we would have to be finding the area of that sector. The problem with finding the area of this sector is that we never know that degree. And if that degree is different and varies every single time we have a cone, it gets a little complicated to find the area of that sector. We would have to set up multiple proportions to figure out the area of that sector. So what somebody did is they decided to come up with a formula that they could use to find the area of every cone, not worrying about that degree. So if you would, next to the picture that you've already drawn, write out this formula. Surface area is equal to the area of the base. So this is the area of the base. The area of the base is pi r squared. That's the area of a circle, right? Plus the area of the weird sector piece around the cone. So the side around the cone, or the piece, if you will. The piece around the cone is pi r, so pi times radius times the slant height. So we do need to have a slant height, if not given one. All right, so let's go ahead and do this example of surface area of a cone. And you need to write this down. Okay, so remember surface area with cones, have a specific, so surface area of the cone is pi r squared plus pi r L. All right, so let's go ahead and use this formula to find the find the surface area of this cone. So first we're going to plug in everything we know. So pi and radius is 5, so 5 squared plus pi times radius times lateral height. Okay, lateral height is the slant height. The L is the slant height. Okay, another way of saying that is the lateral height. So the outside, the sides, or the piece, we don't really know what that is. But if you can see this 3D triangle, we could use that 3D triangle to find the slant height. Okay, so how do we find the slant height? We would use the Pythagorean theorem. We would say 12 squared plus 5 squared is equal to the slant height squared. So 144 plus 25 equals the slant height. That would be 169 is equal to L squared. Square root both sides. and our L is equal to 13. So what I can do is I can now plug that 13 in for my slant height. So now surface area, if you could put this in your calculator, you can. Just make sure that you use parentheses and a plus sign here. I'm going to just go ahead and do piece by piece. The base is 78.5 when I take 25 times pi, plus pi times 5 times 13 is 204.2. And when I add those pieces together, I would get 282.7 centimeters squared. And that would be the area of my cone. All right, that's all we have for today. We'll come back in days to come and practice this. Thank you for taking good notes, and we'll see you soon.